as everybody knows, there's more than one way to look at the world. And Sony's world-renowned Trinitron TVs are well worth looking into. Capturing the legendary sharpness and clarity of Trinitron technology on a screen this big is an accomplishment we're proud of. So is creating the technology to build them. The process begins with the screen itself, which starts out as a clear glass panel. At this point, there are actually two assembly lines which move in tandem, one for the glass panels and one for the metal frames which hold the aperture grille inside. Sony's proprietary aperture grille technology is what makes a Sony TV look the way only a Sony TV can look. In reality, the aperture grille is a carbon steel mask composed of hundreds of precisely registered strips. When the grille is in place behind the TV screen, these ultra-thin metal strips act as a rigid alignment guide to ensure that electrons fired at the screen strike their exact target to create a crystal clear image. Once the aperture grille and frame have been joined together and matched with the glass panel, the completed assemblies are transported to an environmentally controlled process area. Here, the panels are specially prepared and imprinted with fine lines of black carbon. 3 different sets of phosphor stripes, green, blue, and red, are then applied between the carbon lines. The glass back of the Trinitron tube, called the funnel, is joined to the panel assembly, and the electron gun is inserted. Just like the smaller tubes used in our Sony projection TVs, a vacuum is applied and the entire CRT unit is sealed. Finally, the CRT is assembled into the chassis along with the electronics and audio speakers. The completed unit is tested and another top-of-the-line Sony Trinitron TV is on its way to market. You've heard the phrase, the shape of things to come. Well, at Sony, the shape of the future is flat, as in the world's first truly flat display direct TV, the FD Trinitron Wega. The Wega's flat screen design is more than just a fashion statement. It's a combination of engineering breakthroughs that make these new Sonys flat out better. When it comes to our 32-inch and 36-inch Wega TVs, form and function go hand in hand. Where conventional curved screens can create glare and distortion at the edges of the viewing area, the Wega's flat profile and more tightly focused electron beam ensure unparalleled sharpness and detail, top to bottom and side to side, while virtually eliminating unwanted reflections. Creating the flat screen concept was the easy part. The tough part was making it practical. The first challenge was the glass itself. Because the picture tube encloses a vacuum, it needs to be able to withstand the pressure exerted by the air outside the tube, which, in the case of a large screen TV, can represent a force of several tons. Curved screens distribute the pressure more evenly than a flat screen, so the material in the flat screen needs to be much stronger than conventional glass. Of course, it takes more than a screen to make a picture. Other components had to be designed to maximize the new screen's performance. For example, we developed this state-of-the-art high-focus electron gun to permit distortion-free flat scanning and improve image sharpness by as much as 20%. We even improved on our own industry-standard Trinitron technology with a redesigned fine-pitch flat aperture grille that produces the brightest, most detailed images ever. Naturally, to bring it all together, we built the most advanced TV tube manufacturing and assembly lines in the world to build our FD Trinitron Wega. From start to finish, the Wega line sets a new benchmark for excellence in automation, quality assurance, and productivity. And it's all put together just like the world's most popular 35-inch television. Building superior products is a big part of the STCP story, but so is building a competitive company for the future. And with the addition of the American video glass production lines, STCP has become the world's first fully integrated manufacturer of direct-view televisions. Created as a partnership venture between Sony Electronics and Corning Asahi Video Products, the American Video Glass Manufacturing Plant is the largest and most technologically advanced facility of its kind in America. That gives us a truly sand-to-screen capability. Why do we say sand-to-screen? Well, that's because sand is the principal ingredient of the glass components that go into a Sony TV. Sand from central Pennsylvania and other raw materials arrive at the plant via truck and rail car. Here they are mixed according to proprietary Sony formulas and injected into either of two melting furnaces. Two furnaces and production lines are required because the American Video Glass Plant produces two key elements for Sony's Trinitron direct-view TVs: the funnel, which encloses the rear of the picture tube, and the panel, which is the viewing screen mounted at the front of the picture tube. After being heated to 1500 degrees centigrade, pre-measured glass loads are discharged into a mold carousel and pressed into the desired shape. The hot glass forms are then transferred to a conveyor line and allowed to cool. The partially cooled forms travel along a conveyor to a variety of robotic workstations for finishing and inspection. Up to this point, the two lines seem nearly identical, but the end products are very different. Proper shape and material integrity are essential in funnel production. That's because in the finished TV, the funnel must perform as a precision vacuum device capable of withstanding high temperatures, pressures, and mechanical stresses over the life of the product. No flaws or deviations from ultra-fine tolerances are permitted, so each funnel must undergo a battery of sophisticated visual, metric, and mechanical inspections. In contrast, panel glass is heavy, weighing as much as 80 pounds. Panel glass also differs from funnel glass in two other key respects. First, the glass formula includes chemical coloring agents that give the screen its characteristic smoky tint to enhance the quality and brightness of the color TV image. Second, since the panel glass is the viewing area of the TV, it must be finished to the same demanding optical standards as camera lenses and eyeglasses. To achieve that precision, the panels are subjected to a three-stage polishing operation. Polished panels are then inspected by a human operator to detect any physical flaws or variations in color and clarity. To ensure compliance with rigid quality and process specifications, both lines are controlled from central computer rooms, featuring state-of-the-art process control systems and software. In the end, all that care pays off in specialty components that are to video glass what Sony TVs are to consumer electronics, the absolute benchmark of quality and performance.